Welcome back, Genghis. Today we're back again. We're wearing our giraffe drip. So the giraffe drip shirt is going into the item shop today. So if you're interested in something like that, you should definitely cop up. What better animal to represent the act of grinding LeetCode than the giraffe? If we think about it, knowledge is stored in the torso. And jeez. Okay. I have no idea where I was going with that previous statement, but yes, that coughing fit has taken me completely out of the game. I have no idea where we're going with that, but as we can see, we've been instructed by the gods to probably stop talking about it, so we're going to. I don't think we have any. Actually, let me double check. Oh, we do. We have a comment from Yash Solanki, part-time entrepreneur, visionary, author, and best friend. You are motivating me to start challenging myself. Massive effort from you. Hey, big ups, brother. Big ups, brother. Gonna do my best today. You gave me some extra strength. Let us get to the Baggington. So now we have no choice but to get to the Baggington. Yash has given us a buff. The buff will last approximately 20 minutes. So you have to do the best that we can to make sure that we perform. That being the case, it's dummy late. It's dummy late. It is dummy late. So I think we're probably going to do a shorter session today, probably 20 minutes, and then we'll see how the cards land. So actually last night I was eating some Ritz cheddar crackers, the fire ones, the toasted chips. They're kind of a banger, and I hadn't had them in a long time, and then I realized why I stopped having them. I woke up in the middle of the night, and lo and behold, acid, a lava pit was forming in my stomach. So I realize now why we let that go, probably because the ingredients that were used to make those chips can be found in any modern volcano today. So that being the case, our sleep schedule is completely off the rails. I woke up in the middle of the night to take some anti-acids, and here we are. So we need to get some sleep tonight. But before we do that, we can't sleep unless we've done what must be done, unless we've slain what must be slain. We must get the first kill of the day, and that is to be done courtesy of LeetCode.com. So hopefully we can continue working on the problem for some. We started writing some nonsense yesterday, so I'm going to set the timer for 20 and see if we can close this one out. But the best thinking session should last at least 40 minutes. We just don't have that today. So this is where we're at. So we basically have to find 4 indices, and we're given an array of numbers, right? And we're given a target. Given the array of numbers in the target, we should find 4 numbers such that they sum up to equal target. We can solve this in n to the 4th time, right, by running every combination of character. But we know that generating an exhaustive list of numbers only works if we had a list of max size 12. Otherwise, the time complexity required to generate all the potential numbers is simply too great. So what we've decided to do instead is take a modified version of a two-sum solution. So given an array of numbers and a target, we know that we can find the two numbers that sum up to target, right, given a starting number in constant time, assuming we've already looped over the array and added it to a map. So what we've done instead to mimic this solution is to do an n squared loop and iterate over the set of numbers, thereby creating all possible pairs of 2 numbers. Realizing that, we can then take this array of numbers and simply check if two numbers in that array sum up to equal our target, because each number is presumably made up of two individual indexes. So if we had two numbers together, we can conclude that they were formed by four separate numbers, but that's why we have two maps. Two data structures. The first data structure is just an array which keeps all the numbers that we added together. And the second one is a paired map, which given a number like 10, it will give us all the indexes, all tuples, all indexes as a list of tuples that add up to 10. So it looks like we ran this code yesterday, and it looks like we're getting a couple of nonsense answers. So let's see. Our target is 0. Actually, no, this is not a nonsense answer. 1, 1, 0, negative 2 is a valid answer. Just like 1, 0, 0, negative 1. What about 1, 0, negative 1, 0? We also have that one as well. What about 1, negative 1, 0? Ah, I see what's happening. We're getting all combinations of these numbers. We're getting more than we need. We might be able to fix this actually if we also sort the number array. That way when we create the ID, we have no duplicates in here. Oh, we're using the same numbers. Wait, I think we're using... one number more than once. Here we can make sure that the unique indexes, this implementation is an absolute mess. But if we take the ID array and we create a set from it, we can make sure, right, if we make sure that the unique indexes dot size equals 4. Let's see if this doesn't get a crazy amount of TLE. Actually, if we take out the consoles, it should be slow, but it should work. Okay, we just have to remove our consoles. I feel like it should be n squared. This isn't too crazy. But this loop in here is pretty crazy. Maybe we're overcomplicating this. If there's more than one way to form 10, does it really matter? Because ultimately we can't have... Let's cancel out our second half of the code for now. We've done n by n. If we look at the paired numbers, (1, 0, -1, -2, 2. Now that I'm thinking about it, what if we did a simpler version? We have all the numbers that can be formed by adding two numbers together. What if we, instead of having them as single numbers, we had a tuple, right, of the number itself and the indexes it was generated from? Then we could do an n squared loop through this array, right? And we'll just make sure two indexes aren't the same. If they add up to target, then we can make sure that the set is different, and the same thing we were doing before. So we'd push on the sum, and we'll just make sure this is an array of tuples. Should be an array. Oh, I'm modifying the wrong thing. What am I doing? This should be up here. Now, what we'll do is oh man, this hurts my eyes to look at. If we would comment out all this nonsense. Right, and what if we just do for const sum1 indices 1 of paired nums, and then we'll do sum2 indices 2 of paired nums, and then we'll say, put this line here, sum1 indices 1 is equal to paired nums sub I. You can copy this and say sum2 indices 2 paired I sub j. We'll replace this line with this line. We'll change I to j. We'll say if I does not equal j, and then this should be where the magic happens. We just have to make sure that if I does not equal j and sum1 plus sum2 equals target, right? And what else needs to be true? We need to make sure that we have 4 distinct indices. So we'll say indices used equals indices used indices 2, then we can create a set from IDR, and we'll say and IDR.size equals 4, so it's made from 4 unique indices. And additionally, it should be summed using a unique 4 unique characters. And then we'll steal from some lines from the code we just wrote. Then we'll sort it. We'll take out indices will have the number ID. And we'll say and number IDs does not have then we'll do number IDs dot add number ID. We'll do answer dot push number R. I have a good feeling about this one, and it should be faster. I should have commented out that. Let me try it again with no console. What if we did this? Okay, this is gonna sound crazy. What if we did this whole thing again? Except now we could do another. No, this actually doesn't make any sense. It's not n squared anymore. It would actually be n squared. Squared. Oh man, this problem may be impossible. I really felt good about that solution. Maybe that original one is actually a banger. Alright, comment out all this nonsense. This one was really close. This one is just an array of duplicates, though. Wait a second. We can add and nums sub I does not equal nums sub j. Maybe not. I feel there's probably a way to minimize how much work we're doing in these indices here. So maybe that, I think, will be the next move for tomorrow.